So therefore, you'll always end up with your sign in the proper way because you don't have to remember to flip it. Okay? So my lowest variable here is 6x. And so I'm going to add the opposite. I'm doing the opposite. Okay? Just like I don't want to be down, I'm going to get up. That's it. I'm doing the opposite. I don't want to be down, so I'm going to get up. Okay? But what I do to one side, it's like if I try to do it with just one hand, I'm just going to push myself down in the ground, right? I've got to do it to both sides so it's balanced. And that's what this is. So now it is a balanced equation. I'm keeping everything level. All right? So now I've got negative 6 equals 9x minus 18. And now I have the variable and a number with the number on the other side of the equation. It doesn't look just like this, right? But it's the same concept. And now we've got our base. We've got our base. And so now we can start to stand up. Okay? And that first rule of stand up is explosion. Yes?
What does 3x minus 2 equals 8 have to do with 6x minus 6 equals 3?
It's just showing you a basic example of a base.
Okay, because I was like, where did that come from?
Yeah, this is just a basic example of a base. It's just kind of saying, hey, this is what our base looks like.
So that's a base right down there, and that minus 6 equals 9x minus 8.
That's a base. Yes. So we're at our base right there, right? So now it's time to stand up. So to get up, we need to explode, right? We need to explode up. People aren't just going to let you up. You got to get up, okay? And nothing's going to help you solve this. You got to solve it, all right? So we start with technique, good technique. If I push and pop that back, right back into that person that's behind me, into their face, it's going to jar them, okay? Good technique, strong, quick, good moves. Same thing here. Technique here is SADMEP, subtraction, addition. To any variable, you just do the opposite. So whatever is adding or subtracting or adding to the variable. So here's your variable, and I see that this is subtracting from the variable, right? So I'm going to do the opposite. What's the opposite of subtraction? Addition. But again, I can't.
Go to the low one. See, now I'm confused.
Well, the low one was just to move your x.
Oh.
That's it.
See, things change around on me, so I get confused.
Yeah. Because it's just like when you're wrestling, you get to your base, great, but you got to do something, right? So at this point, we're going to push up. But we can't push up with just one arm, right? We need to push up with both arms. So the whole purpose is to push back into your opponent with both arms so it's balanced. So I'm doing the opposite to both sides.
I have a question.
Yep.
So what we're really looking at here, to help with the confusion, is to say when you look at the 6 and the 18, they're both numbers. 18 is larger than 6, right? And so logically, when you add 18 to 18, and you're supposed to add 18 to minus 6, you're going to come out with 12. So, you know, it's like that. Is that how we do it? Because I always saw that since 6 is here and 18 is further away from 0, I would take 18 because it's the larger.
Yes.
It's always easier to subtract the
Now you're
small
not-
from a larger.
Well, you're not choosing the larger one.
No, but I'm talking about as far as is minus 6 is here, minus 18 is here.
Yeah.
6 is over here,
Mm-hmm.
18 is over here, and I'm just seeing it as logically, I would rather subtract 6 from 18 or deal with the, you
Well,
know what I mean? My mind just...
Logically, yes, but what if this were 6 and this were 18? You still need to start with the 6. You need to start with this side. Whatever is adding or subtracting to your
Maybe-
variable.
Then do that,
Okay.
because otherwise I would do it wrong, because
Yes.
I just saw it like this. I saw, okay, so if that was 6 on that side and 18 on that side, then you'd have a minus 18 over here and a minus 6 over there, is that what you say?
Yeah, the whole point is to get your variable alone.
Yeah.
That's the key. I've got to move whatever's over here. If this were a 6, I would move it.
Oh, okay.
If this is an 18, I'm going to move it. It doesn't matter because the point is to get the variable more alone until it's totally alone.
Okay.
And that's good technique. So
Okay.
you start with adding or subtracting the opposite to each, whatever is subtracting or adding to the variable, you do the opposite. Add the opposite to it. Get the variable more alone.
So our number one objective is always to get the variable alone.
That's it. Think of it, you're solving for x.
Okay.
When you think of it like that, you're saying, I want x. Well, if you want x, then you've got to get x
Until you get
by
it.
itself,
Okay, got it.
right?
Yeah.
So that's cool, that's good. Okay, so now what do we do?
Yeah, you did the X by itself.
Yeah, so I can't add or subtract anymore, so I do my next step.
Still
So I
getting it
pushed up, but now I've got to get up, all the way, up and out. So the best way, there's a lot of different ways. You can push back in your opponent, boom, stand up, or you just stand up away from your opponent and get away. Either way,
a wrestling thing.
you want to do this, okay? So what we're going to do is divide or multiply, depending on what's happening to it. Okay? If he's pushing on us, we're going to push back on him. Okay? So if we're either going to push back on him or we're going to go with it. Okay? So if going with it would be like a fraction, we're going to flip that fraction, use the inverted fraction or the reciprocal and get rid of the fraction, and then do the same thing to both sides. So the key here is the same thing. I've got to get to 2 feet. I've got to do the same thing to both sides. I can't just lift this foot and expect to stand up. I've got to get this foot up, and I've got to get up to this foot to be standing. I've got to be on both feet. So what I do to one side, I have to do to the other. So since this is multiplying, I'm going to do the opposite, so that's divide. What I do to one side, I do to the other. And so now I have x is equal to, actually what I really have here is 12 over 9 is equal to x. Okay? And this is what happens sometimes when we have this. Now, if I were to rewrite this as x equals 12 over 9, we don't have much of a problem with that, right? But what if it were less than or equal to x? What happens then when I put the x first?
You have to flip that thing.
Yeah, this greater sign is always pointing. The pointing is always pointing to the same thing. If it's pointing at the 12 ninths, then it needs to point at the 12 ninths. And it's that simple. And so now you have a solution, and you can go even a little further, right? We can go a little further and say that that's really, instead of 12 ninths, it's 1 and 3 ninths, and then break it down even a little further in 1 and 1/3. Okay? And so that's going from your base to your stand-up. Okay? And that's all that is. Okay? So, I think we're good on minutes on that. I can go a little further and talk about exponential rules. Yeah, we got plenty of time. Okay, so,
Excuse me?
yes, sir.
That 12 ninths, the sign you got there?
Mm-hmm.
So the final answer is 12 ninths is greater than x?
Well, that's if I started with this. If I started with this sign,
Oh.
being that way,
Okay.
then the final answer would be.
But right now, x equal 12.
Yeah, we were doing equals, so x is equal to 12/9 or 1 1/3. Good question. Okay, so go a little further with this. We're going to talk about exponential rules. Okay, we need these. And when I talk about these, I'm going to kind of I'm going to take away this, but I'm going to let you write this down for right now. So exponential rules, there's some certain things to exponential rules. So let's talk about those rules.
Is that in
So,
the book?
yep,
Which page?
I'm not sure.
Okay.
Okay, so I have the first rule of exponent is you have x to the a times x to the b is equal to x to the a plus b. Okay, this is keeping in mind that you have x to the a is what we call a power. A is the exponent, and B, or I mean X, is the base. Okay? And so to this monomial, right, there is a power. The power is described by whatever the exponent is, right? But the exponent is just that piece that's up on top of it. Okay?
What
Then
is-
you have the base.
A
So together
monomial?
they're the power.
You call it a monomial because there's only one
Yep.
variable, right? Or no?
No. Because there's, like right here, this would be considered a binomial right here.
Oh, because there's more than one thing.
Because there's more than one house on the
One
block.
thingy.
More than one house on the block.
See? So when you get down to here, you got two houses here. Because houses are separated by fences. Fences are the plus or minus signs. Terms are separated by pluses or minus. So if you have more than one term, then it's going to be more than a monomial. In this case, there's two terms, and so therefore it is called a binomial.
Or a polynomial. But
Or a
because there's
polynomial.
only two,
You can call it a bi. If there's three, it's tri. Anything more than three is always poly. A polynomial is a monomial, a binomial, or a trinomial. They can all be called poly, even though poly means many and one aren't really copacetic with mono meaning. But it's still this is still a monomial or a polynomial, as long as the exponent isn't negative.
Excuse me.
If the exponent's negative,
Okay, I'm just gonna try and stick to
it's
one
not a
thing.
polynomial.
Sorry,
Yeah.
all this information.
stop,
and
stop,
I'm gonna
stop,
get
stop.
confused.
You just said that a
Get the base
Monomial.
monomial is the same as a polynomial. I would not have got that. I would have thought a monomial, because there's only one house,
Yeah.
cannot be a polynomial, because poly is more than one.
Yeah, but polynomial is just the name of the structure that you're talking about. Just
Okay.
because it says many could be one. To
Okay.
some people, right? If I had one Ferrari, it'd be a lot to me,
Got it.
right?
Okay.
So many can be just one.
So poly in this instance just means something.
Yeah,
Okay.
it's just the name.
Okay.
Okay, so we've got this rule. When we're multiplying powers that have the same base, we add the exponents. When we multiply powers, or when we divide powers that have the same base, we subtract exponents. When we take a power of a power, then we multiply exponents. Okay? And now I'm going to start erasing. Wait, because I need space. And I have no eraser here. Sorry. Why do I have no eraser?
Uh-oh.
Here,
He tells me that, right?